Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, Professor of Mathematics at Cosumnes River College in Sacramento, California. This is another review video for a college algebra student who just needs to review solving equations. In this case, we're going to talk about solving equations involving rational exponents. If you didn't watch my 30,000 foot view video, that's okay, but I'm going to be doing some things here that I mentioned in that video. So you might want to, if you didn't watch it, go back and watch that video. And because this is a review, I don't go into the methods too much. I just say, recall, this is how you do this, that type of thing. So let's take a look at solving this equation right here. The very first thing I'm going to do before I go and do anything else is try to visualize what that exponent really means. Remember, rational exponents, they mean that the numerator is the power and the denominator is the root or the index of the radical. And what I mean by that is that this equation could have been written as the square root of 2x minus 1 raised to the third power and then minus 64 is equal to 0. By the way, you should probably note that this is the same thing as the following. If you don't recall that, I highly recommend reviewing rational exponents, but those two statements are identical statements. Now, honestly, I probably would not even begin writing it this way, either of these ways. I'd just leave it as a rational exponent. However, I write it this way for your benefit because you have to note this is a square root of 2x minus 1 here. And that means 2x minus 1 has to be greater than or equal to 0. So let's write that down. So this just lets me know that whatever answer I get in the end for this equation, I need the answer to be greater than or equal to 1/2. That is not my answer right now. That is just a restriction on my answer. So going back to the original problem, let's go ahead and start solving. The first thing I'm going to do is add that 64 to both sides. And now when you want to solve an equation involving rational exponents, you raise both sides to the reciprocal exponent power. That is, I will take the left and the right hand sides and raise both sides to the 2/3 power. If two quantities are equal, then powers of those quantities are also equal. And probably one of the things that I've repeated over and over again in video series that I've been recording through the years is that the law of exponents creep up all the time. And so you could see there's actually a law of exponents occurring right here on the left-hand side. I'll write it over to the right here just to remind you of the law of exponents. A base to the nth power, then raised to the nth power, is equal to the base to the product of m and n power. That is, powers to powers multiply. And so that left-hand side can really be cleaned up. And this is why we had raised both sides to the reciprocal exponent power, is because of these cancellations that occur here. You now have 2x minus 1 to the first power on the left-hand side. And on the right-hand side, here's my recommendation for all elementary and intermediate algebra students when you're dealing with rational exponents on constants. Remember that denominator in the exponent is the root, and the numerator in the exponent is the power. So I always recommend apply the root first. So what is the third root of 64? If you said 4, you're absolutely correct. Notice we still have the power remaining, so let's go ahead and clean that up. Now that we're to this point, it's just a simple linear equation. And I boxed that up. I should have held off a little bit. I want to mention here that we get this answer of 17/2, but I need to make sure that answer satisfies this condition right here. And it totally does. 17/2 is definitely greater than or equal to 1/2. You could, if you want to, check your work. but I'm not going to. Mainly because all of my mathematics was done correctly. I didn't suffer any domain or range issues here. Although I didn't actually mention to you that there is actually a range issue on the left-hand side, but I figured I would reserve that for a secondary conversation at the end of this. Now let me just go ahead and approach that idea of the range issue. Let's pretend for a second that the original equation was this. It's very similar to what we were handed, but this time there's a plus 64 instead of a minus 64. I would still start this problem the same way. I would just say, oh look, 2x minus 1 has to be greater than or equal to 0. Or in other words, that x has to be greater than or equal to 1/2. But then when I would start solving this for x, the first thing you do is start isolating the expression involving x. So I'm going to go ahead and start isolating that. That's 2x minus 1 to the 3/2 power equals a negative 64. And that negative 64 is basically setting off bells in my head. Remember that this exponent means that we're taking the square root of something and then raising it to the 3rd power. The square root always returns non-negative values. Now imagine you have the square root of something. So in here, it's not negative, and then you cube it. That will still not be negative. Yet it's supposed to equal a negative 64. There's no way for that to happen, so I immediately know without going any further, there's no solution. And I saved myself a lot of mathematics and a lot of time by noting that as early as possible. The only difference between this example and the example that we originally started with is the fact that this was a plus 64 here, and in the original example, it was a minus 64. The minus 64, when we moved that 64 to the other side, became a positive, which is okay. Our square root can return positive numbers. So this is just a heads up. These are things that you need to watch out for as you're solving these equations. And now we get to what looks to be a very complex equation. Really, you just need to remember how mathematics works. That often when you're solving equations, the very first thing you want to do is, if you have like pictures in your equation, do some factoring. For example, this x plus 2 is very much like that x plus 2. And this x to a power is very much like that x to the power. So I would like to do some factoring here if I could. And this equation actually gives me the opportunity to remind you of how factoring works. When factoring off a GCF, or greatest common factor, always factor off the lowest powered version of that factor. And this is covered in my factoring video series, so I'm not going to go too much into here other than to just factor. So let's worry about the x here. We have an x to the 1/2 versus x to the negative 1/2. I will factor off x to the negative 1/2 because that's a lower power than x to the 1/2. And now let's focus in on the x plus 2. Of those two highlighted factors, the negative 3rd is the lower of those two, so I will factor off x plus 2 to the negative 3rd power. I'll be left with something, and again, that will be equal to 0. And just to remind you how I did this in previous videos, you would go ahead and say in that first term, I originally had an x to the 1/2, and I had an x plus 2 to the negative 3rd. But factoring is like division. It's not like division, it actually is division. So I'm going to divide off of that old first term there, this factor of x to the negative 1/2 times x plus 2 to the negative 3rd. When I do that division, it'll tell me what my new first term will be. You can easily see the x plus 2's to the negative 3rds cancel. And by properties of exponents, the negative can be ripped off of this exponent, and that would move this upstairs. And that means you'd have x to the 1/2 times x to the 1/2, or in other words, x to the 1st, which is the same thing as x. Now let's go ahead and take a look at the second term. It originally was this 3x to the negative 1/2 times the quantity x plus 2 to the negative 2. But remember, we're factoring off this factor of x to the negative 1/2 times x plus 2 to the negative 3rd. So we factor that off, calling it division. And you can easily see, again, just like it did earlier, the x to the negative 1/2 will cancel there. You'll be left with 3, and then you can rip the negative off of this and move this whole factor upstairs. So 3 times x plus 2 to the negative 2 times x plus 2 to the positive 3, you would add those exponents and you would get 3 times x plus 2 to the first. That's what that factoring would do. It would leave us with a positive 3 times the quantity x plus 2. All of that work leads us to the following statement. This implies that the original equation could have been rewritten as x to the negative 1/2 times x plus 2 to the negative 3rd times 4x plus 6. That's just me distributing and collecting like terms here. Now, you know about negative exponents. There's not much for me to explain here other than to say that this could have been written as 4x plus 6 over x to the 1/2 times the quantity x plus 2 to the 3rd, and that would all equal 0. Something very special about equations involving fractions is that the only way for a fraction to become 0 is if the fraction's numerator is 0. Before I go down that road, I want to mention something here. Looking at that denominator, this x to the 1/2 being in a denominator, first of all, that tells me that x cannot be 0 because we'd be dividing by 0, but also that's the square root of x. So not only cannot be 0, but it has to be positive because you're taking its square root. The second factor here, x plus 2 to the 3rd power, well, that just tells us that x plus 2 cannot be 0, or in other words, x cannot be a negative 2. Well, if you take a look at all of these restrictions, really the one that kind of summarizes them all is the one right here. X has to be greater than 0. Obviously, if x is greater than 0, then it's not negative 2, and it's not 0. So in the end, whatever answer I get, it had better be positive. So going back to where we left off, we have this fraction, it's equal to 0. The only way a fraction can become 0 is if its numerator is 0. So let's go ahead and solve when is 4x plus 6 equal to 0. And that occurs when x is equal to a negative 3/2, a negative 6 over 4. However, we have a restriction. X must be positive, and we get this answer that x is equal to a negative 3 over 2. That is not positive, so that can't be in our solution set. I cross it out. It was the only solution that we got, so therefore there are no solutions to this equation. Now, something I want to mention here. This is not the only way you can solve this equation. And I don't want to force your hand to do something that is unnatural for you or that you have a method that just works better for you. So let me showcase what a lot of other students will do. And like I said, there's nothing wrong with doing it the second way. Let's go ahead and just copy down the original problem. So taking a look at this, one thing you could have done right from the get-go is go ahead and remove those negative exponents by dropping things into denominators. So for example, that very first term could have been written as x to the 1/2 over the quantity x plus 2 to the 3rd plus, and then the second term could be written as 3 over x to the 1/2 times x plus 2 squared. And this is all equal to 0. From the beginning, I would then mention some restrictions on x. For example, this first guy right here tells me that x cannot equal a negative 2. The second group tells me, well, x can't equal negative 2, but that's okay, I already have that written down. And in this case, x must be greater than 0, because again, it can't be 0, I'd be dividing by 0, and it's a square root, so it has to be positive. Of those two conditions, the x being greater than 0, again, is the one that supersedes the x cannot be negative 2. And I know that students love to group these two fractions together. You don't have to, but students love to do it. So let's just pretend that you find the LCD and add up these two fractions. The LCD here would be x to the 1/2 times x plus 2 to the 3rd, because you need x plus 2 to the 3rd because of that guy, and you need x to that 1/2 because of this guy, and x plus 2 to the 2nd is taken care of because the x plus 2 to the 3rd. So let's go ahead and multiply that first fraction by x to the 1/2, both numerator and denominator. And the second fraction will multiply both numerator and denominator by x plus 2. When you do that, they should have the same denominators, and you get that x plus the quantity 3 times the quantity x plus 2 over x to the 1/2 times the quantity x plus 2 to the third must equal 0. Again, we already mentioned the restrictions on that denominator, so there's no need for me to mention that again. And we'll go ahead and glue together this stuff in the numerator. Again, if you have a single fraction equaling 0, the only way for a single fraction to equal 0 is if the numerator of that single fraction is 0. And solving that equation, we get to the same supposed answer, but again, it's a -3/2, and we have a restriction. X must be positive. Because we got an answer that doesn't satisfy that restriction, this answer, again, same answer as before, is extraneous. So in either case, when we solved this equation, we got to no solution. Generally speaking, that's how you would answer a question like this, although I use an online homework system that uses the notation DNE if there's no solution, which is not really a great way to say it, but that's okay. It does not exist as another way of saying no solution. So that's a very brief review of solving equations involving rational exponents. You will see these styles of equations and expressions involving negative rational exponents and rational exponents in general as you move towards calculus. And within calculus, you see them quite a bit. Anyhow, that's it for this video. I hope you learned something here or that it was just a good refresher for you, and I'll see you in the next video.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.